Hi, in this video I'm going to explain the first example of this net change theorem. Actually, I'm going to split this one in 3 short videos. So let's start with this right away. Here it says a ball is thrown up with an initial velocity of 96 feet per second. Here I have the diagram of the situation. Its acceleration from gravity is negative 32 feet per second squared. So the question here is, what is the net change in velocity between 0 and 6 seconds? So starting out from where we left on the previous video, we got to this diagram that we can use to solve these kind of problems. So the net change in velocity, we're going to start with this formula as well, which is the formula for the net change theorem. So we're saying that if we integrate the derivative of a function, we can get the net change in its value in general sense. So what is the derivative of velocity in this case? The derivative of velocity would be the acceleration. So basically what we're having here, I'm going to, in the terms that we have in this problem, would be between 0 and 6, we have to integrate the derivative of velocity, which is the acceleration, the a of t dt, and we will get to this, will be v of 6 minus b of 0. Now, so let's put it in the context of this problem. So I'm going to do this. What is a of t? What is a of t? Well, we have this information. This says the acceleration from gravity is negative 32 feet per second squared. So we can consider that the acceleration it's actually constant, which stands for negative 32 feet per second squared. So let's see. Would be, I'm going to do it here in the center, would be between 0 and 6. Now the gravity would be negative 32 feet per second squared. It will be this dt. Now this is a constant, so its integral, its antiderivative would be negative 32. I'm going to write here feet per second squared. This will be times the time. And we're going to evaluate this for 6 and 0. So let's see, let's evaluate this out. It will be equal to the negative 32. I'm going to write it fully so you see. Seconds squared will be times 6 seconds will be here. This is the first part, the evaluation. Will be minus, this will of course cancel out. I'm just going to write it to have the full setting. 32 feet per second squared times 0 seconds, 0 seconds. And of course we can cancel out this one. We can cancel this. On the first term we can cancel out these seconds with one of these guys. And at the end we have the net change in velocity will be equal to negative, it will be 6 times 32, which is negative 192 feet per second. Now the first thing I want you to notice is that the units actually make sense, because we have, if we're looking for a net change in velocity, we should have a measure of distance over a measure of time. So now what this means is negative 192 feet per second stands that after the initial velocity, which was at 0 seconds, and this initial velocity was 96 feet per second, then we have a change of negative 192 feet per second, which is this is just negative 192 feet per second less than the actual initial velocity. So well, essentially that'll be it with this problem.